Hello and welcome to our discussion on section 2.7 on solving inequalities. Hopefully by now you've spent a little bit of time looking over my presentations previously on sets and set notation, so that will be important in our discussions here. We're solving inequalities, and so the very first question I might like to ask you is, well, how is a solution set of an inequality any different than the solution of an equation? They do mean two different things. So let's go with a really simple example first to illustrate the difference. Let's say I were to ask you to solve the equation x plus 7 is equal to 10. Well, you know how this one works. If we subtract 7 from both sides equally, subtract 7 on the left, subtract 7 on the right, to balance the equation, we get x equals 3. Well, x equals 3 is the only solution to this equation. And remember that it's a solution because it is the value of the variable that makes the equation a true statement. If we were to put in any other value for x, it would not be a true statement. Let's compare that. Let's say I told you x plus 7, instead of being equal to 10, was greater than 10. What would we say then? Well, just like an equation, we would subtract 7 from both sides. And we would get this statement, x is greater than 3. Well, x equals 3 is no longer a solution, but what does x greater than 3 mean? It means that we actually have many different values that could solve this equation. You could put in x equals 5, and 5 plus 7 would be greater than 10. You could put in x equals 100, and 100 plus 7 would certainly be greater than 10. You could put in x equals 3.1, and that would be true because 3.1 plus 7 is greater than 10. Right? So what conclusion should we come to? Well, the inequality is going to have a solution set that is infinitely big. So there's an infinite number of solutions. Whereas in our simple equation, we only had one, or maybe, depending on the equation, few solutions. Right? So the size of the solution set is a big deal when it comes to inequalities. All right, so there's a few rules that we have to know when we're solving inequalities, and they go like this. There's one rule that says the addition or subtraction property of inequalities, and it says this: if A, B, and C are any real numbers, if A is greater than B, then if I were to add some third number C to both sides of the inequality, then A plus C would be greater than B plus C. In other words, adding C to both sides of the inequality does not change the inequality. The statement would still be true. By the way, this also goes for subtraction. If we subtracted C from both sides, as we showed in our first example right here, that would also be true. By the way, when I make these statements for these rules, it doesn't matter whether I'm stating this for A is greater than B, or A is less than B, or A is greater than or equal to B. Let's try that again. If A is greater than or equal to B, or if A is less than or equal to B, the same rule applies. Another rule, we have a multiplication property. Now, we have to differentiate when it comes to multiplication between positive and negative numbers. So let's state it for positive numbers first. This rule states that if A is greater than B, or less than B, or greater than or equal to B, or less than or equal to B, then A times C would be greater than B times C. We know this to be true because let's get a really basic example right here. If I told you I had 1/2 times x, and I said that was less than 6, if I wanted to find a solution to this inequality, I would do the same thing as an equation, which is I would multiply both sides by 2. Right? Multiplying by positive 2 on both sides gives me 1x on the left, and multiplying by 2 gives me 12 on the right, so x would be less than 12 would be a way of giving me a solution. to this inequality. So what changes if we have a negative number? Well, this rule does give us a little bit of a change. If we said A was greater than B, for example, then multiplying by some negative number C would result in a change of the direction of the inequality symbol. So if A times C, where C is negative, we would have to say that's less than B times C. So we specify and C is negative. Okay. So a really good example of this, let's say I told you that I had negative 3 times x is less than 9. If I divided on both sides by negative 3, by the way, multiplying by negative 3 is the same, dividing by negative 3 is the same thing as multiplying by negative 1/3. If I divided by negative 3 on both sides, we would have to say that x is greater than negative 3 as the solution set. Well, how do we know this is true? I mean, this was negative 3 times x is less than. How do we get this greater than? Well, let's just pick a number and let's check it out. Let's pick a number greater than negative 3 first. All right, let's say that we check it with x equals 0. Does that make it true? Well, certainly. Negative 3 times 0 is most definitely less than 9, so that's true. How about a number less than negative 3? What would happen if you put in x equals negative 4? Well, negative 3 times negative 4 is not less than 9, right? This is not a true statement. So we can see that the numbers actually have to be greater than negative 3 to make this inequality true. So this negative rule is a very important one, and we'll come across this a lot in our next examples.